In today's video, here is a nice problem regarding functional equation. Here is the following statement. We have this application. We have from R to R. We have P of x plus y equals P of x is multiplied by P of y. Okay. Indeed, this is the most useful problems which is given in the Math Olympiad. By the way, don't forget to hit the subscribe button and support our channel by like and comments. So let's go ahead get started with this one. So the first thing that I'm going to start with, so let's give y equals 0. Okay, first y equals 0. I will have a reduced expression. I will have P of x equals P of x is multiplied by P of 0. Okay. The common mistake here, when you divide both sides by P of x and you get rid of P of x, we leave P of 0 equals 1, which is wrong. Okay. Because if P of x equals 0, we will have a problem. So the worst thing here, we are going to lose one of the solution. Okay, this is the problem. So first, let's bring these two terms to the left. So I get here, then take P of x as a common factor. So I get P of x factor 1 minus P of 0 equals 0. Now we'll have two cases. Case number 1, we will have P of x equals 0 or P of 0 equals 1. Okay, so we don't know yet why P of x equals 0. Sometimes P of x equals 0 is not P of x equals 0, because sometimes there is a constant, multiply this one, make this one equals to 0. Because if constant equals 0, which means 0 is multiplied by this one, is given as 0. Not P of x itself as a function equals to 0. Okay, be careful here. So we are going to figure out at the end, not now. Okay, now when P of 0 equals 1, if P of x different than 0. Okay, now if P of x equals 0 for all x values, as I remember, because we are dealing with a number here, this is P of 0 equals 1 when we have P of x different than 0. Okay, now let's work on this case. This one is not going to give us anything now. Now since we have P of x different than 0, which means this one, you will have a lot of work on that one right here. Okay, let's go back to the original expression here. Let's set y equals k as a new substitution. So replacing this one into this one, I get P of x plus k equals P of x is multiplied by P of k, like this. Okay, before we move on, I'm going to remind you about very important and useful derivative function definition. So if we have the limit of f of x plus k minus f of x is divided by x plus k minus x. Okay, cancel out x from numerator and denominator. Then when we have k is approaching to 0. Okay, so this one equals f prime of x. This is the definition. Okay, so we are going to use this definition here. So in order to transfer this one into this one, I'm going to add minus P of x on both sides. So I get here P of x plus k minus P of x. I get P of x is multiplied by P of k minus P of x. So now I will have something very good here. Okay, now I'm going to divide both sides by k, because now I'm almost to get to the expression that I have as a definition. Okay, let's apply the limit on both sides when we have k is approaching 0. Okay, so we get the limit of P of x plus k minus P of x is divided by k when you have k is going towards 0. So here I'm going to take P of x as a common factor, and also I'm going to take it as a constant because we are applying the limit depending, because the limit is depending on k, not x. So now p of x becomes a constant for the limit. Okay, so we get p of x, the limit of p of k minus number 1 all over k when we have k is approaching to 0. Okay, this one is immediately is going to replace with p prime of x by the definition. Okay, so if you take a look here, we know the value of 1 equals p of 0. Let's replace that here. So I get here number 1, it will be replaced with p of 0. Okay, like this. Then adding minus 0 here. So also we get the same definition here. Okay, because k minus 0 is supposed to be x plus k minus x. I have in denominator x plus k minus x. So I have k here, p of k minus p of 0. So divided by k minus 0. Okay, so also this one, it will be replaced with p prime of 0. Okay, I will have a very nice thing here. Now I have ended with this expression. I get p prime of x, which equals p prime of 0 is multiplied by p of x. So since we have p prime of 0 is a constant, this one is arithmetically constant, so let's replace it with lambda 1. Okay, p of x. Now we get p of prime x here, we get p of x here, we get here this one p of x over p prime of x over p of x plus lambda 1, integrating both sides here, dx, I get here dx. Okay, so this one is giving us natural log of p of x, absolute value, because we must keep inside of the natural log positive. So we get lambda 1, so the primitive of this one, the primitive of this one, which is x. But don't forget the constant. Okay, let's put the constant c. We are going to take this p of x out of the natural log. Let's put it on the form of the exponent. So I get exponential here. I get p of x equals exponential of lambda 1 x is multiplied by e to the c, because I have e to the lambda 1 x plus c. This one I'm going to separate this one, put it as a constant. Let's put this one as a constant as well. Let's put it as a lambda. Okay, so we get here this one equals lambda is multiplied by e to the lambda 1 x, like this. Okay, let's take this expression at the top and determine the constants. Now we need to determine these constants, since we have this condition p of 0 equals 1. If you replace this value into this one, so let's do that. So we get p of 0 here by replacing x with 0. I get lambda here, I get e to the 0, which is lambda. We know p of 0 equals 1, so this one is telling us lambda equals 1. This is a wrong start. Do not do this one. Okay, this is not the best way to determine the constant, because we found only one case, lambda equals 1. Okay, what about we found before p of x equals 0? Okay, so what makes p of x equals 0? Where is p of x equals 0 comes from? You see this function has a general expression, so why p of x equals 0? What's the condition make p of x equals 0? So instead to use this one, let's use the general expression, okay, in order to determine the constant by going back to the original expression. So replacing now the same thing here, I'm going to put p of x plus y, which equals lambda is multiplied by e to the lambda 1 x plus y, like this. Then replace this p of x as you have it here. Lambda is multiplied by e to the lambda 1 x, then is multiplied by again by lambda e to the lambda 1 y. Okay, let's put this one together now. Let's put it, this one, I have a lambda square here, is multiplied by e to the lambda 1 x plus y. as an exponent. Okay, if you take a look here, this term is the same as this term, so let's cancel it out. Why? Because it's different than 0. This one is impossible equal to 0 since we have exponential here. Okay, so that's why we are dividing both sides by this one. Now I will be left with lambda equals lambda 2. And then another mistake when you divide both sides by lambda. Okay, don't divide both sides by lambda. Take always this one to the left, to one side. So we get a lambda. Now I will be left with lambda equals lambda square. Then take one of these values to one side. So I get, for example, lambda 2 minus lambda equals 0. Then take lambda as a common factor here. I get lambda factor lambda minus number 1 equals 0. Now I have two cases. Okay, case number 1, if lambda equals 0, then I'm going to replace lambda with 0 here. I get a new expression of px. P of x equals 0 here. You see now the p of, if you remember, p of x equals 0, which we have previously, now it came from lambda equals 0. That's why we get p of x equals 0. Okay, this is for all x as a real number. Okay, then if lambda equals 1, because lambda is different than 0 here, okay, then replacing lambda with its value here, then I get p of x equals e to the lambda 1x. Now we'll have two things here. So I get p of x equals 0 when we have lambda equals 0. This is when we have lambda equals 1. Okay, now we get the final expression for this one. Now we have ended with this video. By the way, don't forget to hit the subscribe button and support our channel, and thank you for watching. I will see you next video. Bye.